Imagine waking up tomorrow and cutting out every trace of bread, pasta, fruit, and sugar. At first, you might feel proud, strong even, thinking you've hacked your diet. But within hours, your body starts sending quiet distress signals. That's because carbohydrates aren't just calories. They're your brain's favorite energy source. Every cell in your body is suddenly deprived of the fuel it's built to run on. This initial shock triggers a cascade of internal reactions. Your blood sugar drops, your pancreas reduces insulin production, and your cells start to feel starved. Even your mood can shift dramatically as dopamine levels dip, a subtle withdrawal from what scientists call the glucose reward loop. You're not just hungry, you're biochemically unsettled. Most people underestimate how dependent the human body is on glucose. For decades, researchers have documented that even brief carb deprivation can lead to irritability, dizziness, and confusion. The transition from a carb-based metabolism to a fat-based one is not immediate, it's a biochemical battle. And yet, this discomfort is the first step towards something fascinating, a full metabolic transformation. Stay with me, because in a moment, we'll see how your body begins to rewrite its own rulebook for survival. The first 24 to 72 hours without carbs are brutal. Your glycogen stores, the quick-access energy, tucked inside your liver and muscles, begin to empty. Since each gram of glycogen holds about 3 grams of water, you're also losing hydration rapidly. That's why many low-carb dieters feel light but drained. Their weight drops, but so does their vitality. During this phase, fatigue kicks in hard. Your cells are still searching for glucose that simply isn't there. Your brain, which consumes nearly 20% of your daily energy, becomes sluggish. You might struggle to focus, yawn constantly, and feel as if your body's running on fumes, because it literally is. This depletion is often mistaken for weakness or failure, but it's actually a necessary metabolic test. Your body is trying to decide whether to panic or adapt. Most people give up here, right before the most interesting part begins. Because after a few days, something remarkable happens. Your body starts tapping into fat stores as a backup fuel. But the transition isn't smooth, and your internal systems will fight it before embracing it fully. Your brain doesn't store fuel. It needs a constant stream of glucose to function, and it panics when that stream stops. Neuroscientists call this neuroglycemia, a fancy term for when your brain starts running out of sugar. The symptoms are familiar: irritability, anxiety, brain fog, and sometimes even mild confusion. This happens because glucose isn't just fuel. It's chemistry that sustains cognitive clarity. Each neuron depends on it to transmit signals efficiently. When glucose drops, neurotransmitters like serotonin and acetylcholine start to falter, altering your mood and focus. It's almost like being stuck in a fog that caffeine can't lift. Interestingly, brain scans have shown that when deprived of glucose, the brain's activity pattern resembles someone in mild withdrawal. It's not an addiction in the psychological sense, but biologically, it behaves like one. That's why cutting carbs cold turkey can feel eerily similar to quitting a habit. But here's where the story turns. The brain, though stubborn, is adaptable. If you endure the initial mental fog, it begins to explore another source of fuel, one that's been waiting in the shadows all along. When glucose levels remain low, your liver takes charge. It starts breaking down fat into fatty acids and glycerol. The fatty acids can fuel muscles, but your brain can't use them directly. That's when the liver gets creative, converting part of that fat into molecules called ketone bodies, the emergency energy your brain can accept. This marks a historic turning point in human metabolism. Our ancestors likely cycled through the state regularly during periods of famine or migration. What feels like fatigue today was once a survival advantage, a biological adaptation that kept early humans alive when food was scarce. During this transition, your energy may fluctuate wildly. Some moments you'll feel alert and focused, others weak and foggy. It's your body recalibrating, teaching itself to burn a cleaner, steadier fuel source. Think of it as switching from a gasoline engine to a hybrid system. efficient, but requiring a full software update. And once your body completes this update, the real magic begins. You start burning fat for energy, like a metabolic machine. Fat has long been misunderstood. It's not just storage, it's potential energy waiting to be unlocked. When your body enters a state of ketosis, it taps into that potential. Each fat molecule you burn releases far more ATP, the cellular currency of energy, than glucose ever could. That's why many people describe a strange sense of clean, steady energy once they adapt. The transformation doesn't happen overnight. It can take up to 2 weeks for enzymes involved in fat metabolism to fully activate. During that time, you're training your mitochondria, the powerhouses of your cells, to operate on a new kind of fuel. This shift can enhance endurance, stabilize energy, and even sharpen mental clarity. But not everyone adapts at the same pace. Genetic differences, stress levels, and even sleep patterns can influence how quickly your body embraces ketosis. Some thrive, others crash. The process is deeply individual, a reminder that nutrition is never one size fits all. So how long can this new fat-powered system keep you going before fatigue strikes again? We'll explore that in the next section, and what happens when the body begins to signal distress. When carbs vanish, ketones become the hero molecules of the story. Produced by the liver from fat breakdown, these small compounds, beta-hydroxybutyrate, acetoacetate, and acetone, can cross the blood-brain barrier to fuel your neurons. In simple terms, ketones are your body's emergency generator when the power grid, glucose, goes down. What makes ketones special is their efficiency. They produce energy with fewer free radicals, meaning less oxidative stress compared to glucose metabolism. That's why many people on a ketogenic diet often report mental sharpness and stable mood once fully adapted. Their brains are literally running cleaner. However, this shift isn't effortless. During the adaptation phase, your body juggles electrolyte imbalances, dehydration, and hormonal recalibration. It's like your metabolism is rewriting its operating manual on the fly. Some people experience keto flu, headaches, fatigue, nausea, a sign that your cells are learning a new language of energy. Still, once this phase passes, your system stabilizes. You become a fat-burning machine, more resilient, less hungry, and capable of surviving longer without the ups and downs of blood sugar crashes. Even though your body adapts, it doesn't do so quietly. In the early and mid stages of carb deprivation, your body sends out distress signals. These can include muscle cramps, dizziness, and sudden fatigue, all signs that your electrolytes, especially sodium and potassium, are running low due to water loss. This stage can feel confusing because your weight may continue to drop even as you feel weaker. That's not fat loss alone. It's mostly fluid and glycogen depletion. Athletes, in particular, often hit a wall here, experiencing reduced performance as their bodies still crave quick energy that fat can't provide instantly. Hormones also start to shift. Cortisol levels may rise as the body perceives starvation stress, and thyroid activity can dip slightly to conserve energy. These subtle adjustments are your metabolism's way of protecting you, not punishing you. If you listen closely, your body is communicating. It's not asking for surrender, just balance. Small reintroductions of carbohydrates at the right moments can help maintain metabolic flexibility without breaking adaptation completely. Have you ever wondered why some people can fast for days while others crash within hours? The answer lies in genetics, training, and metabolic flexibility. Some individuals have a natural advantage. Their mitochondria, the energy factories inside cells, are more efficient at oxidizing fat. Endurance athletes, for instance, often display enhanced mitochondrial density and enzyme activity. Their bodies are trained to pull energy from fat quickly and efficiently. Meanwhile, sedentary individuals or those on high-carb diets rely heavily on glucose and struggle when it's taken away. Interestingly, studies have shown that women tend to preserve glycogen longer and rely on fat oxidation more efficiently than men during fasting periods. It's an evolutionary advantage. Their metabolism prioritizes endurance and survival over short bursts of power. So when fatigue strikes, it's not just about willpower. It's a reflection of how well your body's machinery can pivot when its favorite fuel disappears. And in that adaptability lies the secret to long-term resilience. As your body grows accustomed to ketosis, there's a fine balance between thriving and overdoing it. When energy intake drops too low for too long, the same mechanisms that once protected you can start to backfire. Muscle tissue may begin breaking down for amino acids to fuel vital organs. The liver, overworked from constant fat conversion, can become strained. In extreme cases, dehydration and electrolyte loss may lead to arrhythmias, irregular heart rhythms. These are rare but real risks in prolonged carb deprivation without medical supervision. What's fascinating is how quietly the body transitions between balance and breakdown. One day you feel sharp, light, and unstoppable. The next, you're dizzy and disoriented. This unpredictability is what makes long-term carb elimination so complex. Science shows that the key isn't total avoidance, but strategic cycling. Reintroducing small amounts of carbohydrates periodically can reset hormone levels, replenish glycogen, and prevent metabolic burnout, ensuring adaptation never turns into exhaustion. Not all bodies process the absence of carbs the same way, and one of the most overlooked factors is your microbiome, the vast colony of bacteria living in your intestines. These microbes thrive on different nutrients, and when carbs disappear, their ecosystem shifts dramatically. Some gut bacteria rely heavily on fiber and resistant starch, both carbohydrate sources, to produce short-chain fatty acids like butyrate, which are essential for colon health. Without them, the gut lining can weaken, leading to inflammation or sluggish digestion. That's why long-term ketogenic diets sometimes require strategic fiber reintroduction. Genetics also play a huge role. Certain people carry gene variants that influence how efficiently they produce ketones or transport them into cells. Others may have enzyme differences that affect fat oxidation speed. It's one of the reasons some thrive on keto, while others feel perpetually drained. Your response to carb deprivation isn't random. It's written in your DNA and shaped by the invisible ecosystem inside you. The science of personalized nutrition is uncovering just how much these internal variables define your experience. Have you ever tried cutting carbs completely? How long did you last before the fatigue hit? Share your experience down in the comments. I'm genuinely curious how your body reacted. After several days, sometimes a week or more, fatigue creeps back in, but not from sugar withdrawal this time. It's the fatigue of adaptation. Your metabolism has shifted, your enzymes are different, and your hormonal balance is recalibrating, yet your cells are still catching up with the new normal. At this point, energy levels can fluctuate unpredictably. You may wake up full of drive one day and feel utterly depleted the next. The cause? Your glycogen stores are still minimal, and the fat-burning system isn't always fast enough to keep up with sudden energy demands. Exercise performance typically dips, especially in high-intensity workouts that rely heavily on glucose. Mentally, this phase tests resilience. The brain, though now partially fueled by ketones, still craves stability. It's described as living in slow motion. Focus flickers, motivation wavers, and emotional lows surface. It's the body's way of saying, I can sustain this, but not forever. Science shows that most people hit this fatigue threshold between 1 and 2 weeks of complete carb elimination. Beyond that, only those with extreme adaptation or medical supervision can maintain balance safely. Muscles are both victims and survivors in this process. When carbs vanish, glycogen, the stored form of glucose in your muscles, depletes rapidly. That means less fuel for contraction, slower recovery, and an early sense of exhaustion during workouts. However, your body is smart. Over time, it shifts strategy, sparing muscle tissue by using fat and ketones as primary energy. Protein breakdown slows and muscle catabolism stabilizes. This is one reason some people on ketogenic diets can maintain muscle mass, though building new muscle becomes harder without insulin spikes to drive protein synthesis. Still, the early stages can be brutal. Your muscles feel heavy, coordination falters, and power output drops. It's not weakness, it's chemistry. The body is still learning to extract maximal energy from fat oxidation. Athletes often need weeks, even months, to regain peak performance under low-carb conditions. So while you may look leaner, your strength temporarily suffers. The lesson here? Fat as fuel can sustain, but glucose still defines power. And evolution designed us to use both. Here's where things get paradoxical. Once the brain fully adjusts to using ketones, some people report laser-like mental clarity, almost euphoria. Others, however, experience the opposite: fog, indecision, and irritability. Why such a difference? It's all about balance. Ketones provide a steady energy stream, but neurotransmitter synthesis still depends on glucose. Without enough of it, serotonin and dopamine regulation can falter, affecting mood and motivation. That's why prolonged carb restriction sometimes leads to emotional flatness or anxiety. But there's another layer, the evolutionary one. During famine, mental focus would sharpen temporarily to help early humans find food. Once survival stretched too long, mental decline set in. Nature's way of forcing us to seek carbohydrates again. Our biology is wired for cycles, not permanent deprivation. So while your mind may feel sharp for a while and then collapses, it's not failure. It's evolution whispering, it's time to eat again. Reintroducing carbs after days or weeks without them feels almost electric. Blood sugar rises, insulin returns, and your cells light up like they've been waiting for the signal. Muscles refill glycogen, water returns to tissues, and within hours, energy and mood soar. But this rebound can also trigger confusion. Some feel bloated, heavy, or sluggish. The body overshoots, retaining excess water and reacting to insulin spikes it hasn't seen in a while. That's why nutritionists often recommend a gradual reintroduction, starting with slow digesting carbs like sweet potatoes, oats, or legumes. Interestingly, this phase reveals how sensitive your metabolism really is. After adaptation, even small carb doses can feel powerful, proof that your body has become more metabolically efficient. It's like driving a hybrid car that suddenly rediscovers turbo mode. The real takeaway? The goal isn't to banish carbs forever, but to understand their role. When used wisely, they can recharge your system without destroying the balance your body fought so hard to build. If you've made it this far, you're probably wondering, if cutting carbs pushes the body this far, what would happen if you stopped eating altogether? Then don't miss this next video. How long could you fast before losing muscle? It dives deep into how your body fights to protect your strength when food disappears. You can watch it right here, and trust me, the science behind it will blow your mind. So how long could you truly live without carbs before fatigue sets in? Science suggests that while the human body can technically survive indefinitely on a fat and protein-based diet, as long as micronutrients are balanced, optimal performance and mental stability tend to decline within 1 to 3 weeks for most people. Elite endurance athletes and those on strict ketogenic diets can extend that period dramatically, sometimes thriving for months. But the key word is adaptation. Without gradual transition, electrolytes, and enough calories, fatigue becomes inevitable. In the end, the answer isn't a single number, it's a range defined by biology, genetics, and lifestyle. The body is a master of adaptation, but it never forgets its original blueprint. Carbohydrates remain the preferred, fastest, and cleanest fuel when balance is restored. So, next time someone claims they've cut carbs completely, remember, the question isn't if fatigue will come, but when. And when it does, it's not weakness. It's your biology asking for equilibrium once again. Now that you know what really happens when carbs disappear, would you ever try it yourself? Comment below what surprised you the most. And don't forget to like, subscribe, and share this video so more people understand the real science behind fatigue and energy.